Hello students, welcome back to the class. This is the part 7 of some basic concept of chemistry. This class we are going to study about mole concepts and molar mass, percentage composition, empirical formula and molecular formula. Let us study one by one. Mole concept and molar mass. Mole concept. You studied that table, that SI unit table, right? What is the SI unit of amount of substance? That is mole. Now, what do you mean by mole? If suppose 1 dozen apple ಇದೆ ಅಂದ್ರೆ ಎಷ್ಟು number of apple ಇದೆ? It is 12, right? Same 1 dozen grapes or 1 dozen banana which contains 12 numbers, right? 12 number of banana which is equal to 12 number. 1 dozen ಆಗಬೇಕು ಅಂದ್ರೆ 12 number of items or substance ಇದ್ರೆ ಮಾತ್ರ ಅದು 1 dozen ಅಂತ ಹೇಳ್ತೇವೆ. Same that concept you considered in this microscopic particles, that is atoms, molecule or ions. 1 mole which is equal to 1 number, that is Avogadro number. See, 1 mole is the amount of substance that contains many particles. As many particles it may be atom, ion or molecule or entities. As there are atoms in exactly 12 gram of the carbon 12 isotope. You know that carbon 12 isotope, right? That atoms are exactly in carbon 12 gram of the carbon 12 isotope. So now what is the mass of carbon 12 atom? One atom na carbon 12 atom na mass eshtu? It is determined by other method, that is 1.992648 into 10 to the power of minus 23 gram. Now if you divide this 12 gram per mole of carbon 12 divided by the mass of one atom of carbon 12 isotope, we get one constant, that is Avogadro constant or Avogadro number, that is 6.022 into 10 to the power of 23 atom per mole. It is very, very important. This number is called it as Avogadro constant or Avogadro number. This entities in mole is so important, that is given separate name and symbol. As I already told, it is Avogadro constant or Avogadro number denoted by Na. N subscript A. Now 1 dozen apple which is equal to 12, right? So like that, let us see chemistry terms. That means 1 mole of hydrogen atom which is equal to Avogadro number of atoms, that is 6.022 into 10 to the power of 23. In case of here 1 dozen apple which is equal to 12, right? 12 number change agala, ಏನೇ substance change ಮಾಡಿದ್ರು, in place of apple we put banana, 1 dozen banana is equal to, it is 12, right? Or half dozen banana equal to, it is 6. That number change ಆಗ್ತದ? ಆಗೋದಿಲ್ಲ. Same like that here 1 mole of hydrogen atom which is equal to 6.022 into 10 to the power of 23 atoms. Like that 1 mole of water molecule which is equal to, in terms of molecules ಅಲ್ಲಿ ಹೇಳಬೇಕು, atoms ಅಲ್ಲಿ ನಾವು ಹೇಳಿದಾಗಲೂ ವ್ಯಾಲ್ಯೂ ಅಷ್ಟೇ ಇರ್ತದೆ, Avogadro ನಂಬರ್ ಆಗಿರುತ್ತದೆ. 1 mole which is equal to Avogadro number of particles. 1 mole of water molecule which is equal to 6.022 into 10 to the power of 23. Water molecules here in terms of molecules. 1 mole of sodium chloride which is equal to 6.022 into 10 to the power of 23 formula units of sodium chloride. In terms of formula units ಅಲ್ಲಿ ಹೇಳಬೇಕು. You studied formula mass, molecular mass, atomic masses, right? So 1 mole which is equal to 6.022 into 10 to the power of 23 atom, that is Avogadro number. This is about the mole concept. Amount of substance anna ಒಂದು unit ಅಲ್ಲಿ express ಮಾಡಬೇಕು, that is SI unit, that is mole. Then molar mass. See, we studied about molecular mass, right, in unified term. What is the molecular mass of H2O? It is 18.01, right? 01 U anta ಬರ್ದಿದ್ದೀವಿ, ನೆನಪಿದೆಯಾ, in the previous class. Here molar mass of 1 mole of a substance in gram, it is called molar. It's molar mass. Molecular mass anne in terms of gram alli bardre it is 1 mole of substance anna gram alli represent ಮಾಡಿದೀವಿ ಅಂದ್ರೆ it is molar mass. Or molecular mass anna in terms of gram alli ಬರ್ದಿದ್ದೇವೆ ಅಂದ್ರೆ gram molecular mass. Gram term anna express ಮಾಡ್ತೇವೆ. Usually we wrote in terms of unified mass, right? Here the mass of 1 mole of a substance in grams, which is equal to its molar mass. See, let us take some examples. See, before that, the molar mass in grams is numerically which is equal to atomic or molecular or formula mass. That one only I told. In terms numerically which is equal to atomic or molecular or formula mass. In unified mass, this is very important, in unified mass. So molar mass of water, that is 18.02 gram per mole. Then molar mass of sodium chloride, which is 58.5 gram per mole. This is, in previous class we studied as formula mass, right? This is molecular mass. So molar mass of water, it is 18.01 or 02 gram per mole. Understand? Then, so far we studied, we were dealing with the number of entities present in a given sample, right? But many times the information regarding the percentage of particular element present in the compound is required. For example, water alli hydrogen na percentage estide anta kelidre helbekalva. So we have to calculate the percentage of particular element in a compound. For that percentage composition we have to study. Suppose an unknown or new compound is given to you. The first question you would ask is, what is the formula, or what are its constituents, in what ratio that are present in the compound? These are the first basic questions. You need to study that one. So percentage composition is one formula is there. Mass percentage of an element. ಒಂದು ಎಲಿಮೆಂಟ್ ಅನ್ನ ನಿಮಗೆ ಕೊಟ್ಟಿದ್ದೀವಿ ಅಂದ್ರೆ ಆ ಎಲಿಮೆಂಟ್ ನ ಮಾಸ್, ಒಂದು ಕಾಂಪೌಂಡ್ ಅನ್ನ ಕೊಟ್ಟಿದ್ದೀವಿ ಅಂದ್ರೆ ಅದರ ಎಲಿಮೆಂಟ್ ಅನ್ನ ಪರ್ಸೆಂಟೇಜ್ ಎಷ್ಟಿದೆ ಅಂತ we have to study. So mass of that element in the compound, percentage always represented in 100, right? 100%. So into 100 divided by molar mass of the compound. Molar mass you studied. Molar mass, the molecular mass in terms of gram, right? 1 mole of substance in grams we represented as molar mass of the compound. See, let us take one example. One example ante kondaga easy agi artha agtade. See, since water contains hydrogen and oxygen, ಎರಡು hydrogen atom ಒಂದು oxygen atom combine agi namage water sigtade. So what is the percentage of both these elements? That one we have to calculate. First, before that, you should write molar mass of water. Molar mass of water is 18.02 gram. Then mass percentage of hydrogen. In water alli hydrogen na mass percentage ಎಷ್ಟು? So you write this formula. After that, mass of that element in the compound, which is the element, mass percentage of hydrogen means hydrogen is the element. So how many atoms are present? 2 atoms are present, right? So 2 into, what is the atomic mass of hydrogen? It is 1.008 into 100 divided by molar mass of the compound. How we calculated molar mass? Atomic mass into number of atoms present in the compound, in adding those element present in the compound, that is 18.02. So what is the answer? What is the mass percentage of hydrogen in water molecule? That is 11.18%. Then mass of oxygen, which is equal to 16. Oxygen ಒಂದೇ ಇರೋದು. So what is the atomic mass of oxygen? It is 16 into 100 divided by molar mass of the compound. Molar mass of the compound means molar mass of the water. So 18.02. We get the answer 88.79% of oxygen is present in water. One more example. What is the percentage of carbon, hydrogen and oxygen in ethanol? Molecular mass of ethanol is C2H5OH. C2H5OH. What is the name of this compound? Ethanol. Now, first we have to find out the molar mass of ethanol. Carbon 2 is there. 2 into atomic mass of carbon. That is 12.01 plus H. How many hydrogen atom is present? 5 here and 1 here, right? So total 6 is there. 6 into 1.008 and plus oxygen is 1 is there. So it is 16. Total molar mass of ethanol is 46.068 gram. Molar mass in the denominator. Always molar mass of the compound is in the formula denominator. For that purpose, we have to calculate first molar mass of ethanol. Mass percentage of an element. Now, see, first you should write the formula, then calculate one by one element of mass percentage of that particular element. So, mass percentage of carbon. Carbon, it is 2 is there, right? What is the atomic mass of carbon? It is 12.01 into 2. Carbon 2 is there. So into 2, we get 24.02 gram into 100 divided by molar mass of the compound. So we can get answer 52.14%. Then mass percentage of hydrogen. Hydrogen total 6 is there. 6 into 1.008. We can get the mass of that element in the compound 6.048 gram into 100 divided by molar mass of the compound. That is 13.13% of hydrogen present in the ethanol. Then mass percent of oxygen. Oxygen, only one atom is there in ethanol, right? So 16 into 100 divided by 46.068. That is molar mass of the compound. That is equal to 34.73% of oxygen which is present in the ethanol. This is the way, this is the step to find out the percentage composition of the element in the compound. This is very important numerical formula. I given here 2 examples. Study well this topic. One question from this topic may come in the exam. Then empirical formula and molecular formula. Both formula are very, very important in board exam also. First, you should understand what is the empirical formula and molecular formula and what is the relation between those empirical formula and molecular formula. See, first we study empirical formula. An empirical formula represents the simplest whole number ratio of various atoms present in a compound. See here, C6H6 is the molecular formula of benzene, right? Now, carbon 6 atom is there, hydrogen 6 atom is there, right? So what is the simplest whole number ratio? Whole number ಆಗಿರಬೇಕು and simplest whole number ratio ಆಗಿರಬೇಕು. But molecular formula 6:6 ratio, 6:6 ratio ಇದೆ, right? So we have to reduce the simplest whole number ratio, that is 1:1, right? If 6:12 is daga, that is 1:2 is the simplest whole number ratio. But here 6:6 ಇದೆ, so we have to reduce the simplest whole number ratio, that is 1:1. So that is the empirical formula of benzene. An empirical formula represents the simplest whole number ratio of various atoms present in a compound. Various atom idaga adara simplest whole number ratio vana empirical formula anta kariteve. CH is the empirical formula of benzene. C1 is there, H1 is there. So that is in 1:1 ratio. That is call it as empirical formula. Now molecular formula. Molecular formula shows the exact number of different types of atom. Exact number of atom anna molecular formula represent ಮಾಡ್ತದೆ. Exact number of different types of atom present in a molecule of a compound, that is C6H6 is the molecular formula of benzene. Benzene is an aromatic compound, that is we will study in hydrocarbons in organic part later. So relationship between empirical and molecular formula. What is the relation between empirical and molecular formula? One formula is there. Molecular formula is equal to N into empirical formula. So we can calculate it N by empirical formula is in denominator. So molecular formula divided by empirical formula will get the number N. Molecular formula is equal to N into empirical formula. This is the relationship between molecular formula and empirical formula. This type of question is definite question in the annual examination. You have to find out the empirical formula and molecular formula. There are given percentage composition and molar mass. You have to find out empirical formula and molecular formula. See, a compound contains 4.7% of hydrogen. This is the percentage composition of hydrogen. ಒಂದು ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ನ ಪರ್ಸೆಂಟೇಜ್ ಎಷ್ಟಿದೆ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಅಂಡ್ ಕಾರ್ಬನ್ ನ ಪರ್ಸೆಂಟೇಜ್ ಇಟ್ ಈಸ್ 24.27 ಅಂಡ್ 71.67% ಕ್ಲೋರಿನ್ ಇದೆ. ಹಾಗಿದ್ರೆ ಒಂದು ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ ಹೈಡ್ರೋಜನ್, ಕಾರ್ಬನ್ ಅಂಡ್ ಕ್ಲೋರಿನ್ ಇದೆ ಅಂತ ಆಯ್ತು. ಫಸ್ಟ್ ಯು ಶುಡ್ ಥಿಂಕ್ ಲೈಕ್ ದಿಸ್. ಅಂಡ್ ಮೋಲಾರ್ ಮಾಸ್ ಅನ್ನ ಕೊಟ್ಟಿದ್ದಾರೆ. ಮೋಲಾರ್ ಮಾಸ್ ಇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸ್, ರೈಟ್? ಸೊ ವಾಟ್ ಈಸ್ ಇಟ್ಸ್ ಎಂಪಿರಿಕಲ್ formula and molecular formula? See, you should draw this table and list out, make 6 columns, right? What are the 6 columns? Elements, symbol means hydrogen symbol, element separate symbol is. So percentage of element, that is given in the problem. Atomic mass of the element, that should you should know this atomic mass of element. Then you have to find out moles of the element and simpler molar mass. Hydrogen, H is the symbol, percentage given, that is 4.07, and atomic mass of hydrogen is 1.008, right? Then moles of the element, how to calculate moles of the element? That is percentage of element divided by atomic mass. Percentage of element divided by atomic mass, that will give moles of that element. Then next carbon, this one later we'll see. Carbon 24.27% is there, atomic mass is 12, so percentage of element divided by atomic mass will give moles of that carbon atom. Then chlorine 71.67 is there, 35.5 is the atomic mass of element. Then moles of the element, moles of the chlorine, how many moles is there? That is a 2.018 mole is there. See, you compare these 3 value, 4.07, 4.07, 2.022 and 2.018. Which is the lowest value among these three? ಯಾವುದು ಇದರಲ್ಲಿ ಲೋವೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂ ಅದನ್ನ ಸಿಂಪ್ಲರ್ ಮೋಲಾರ್ ಮಾಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡುವಾಗ ಯೂಸ್ ಮಾಡಬೇಕು. In these three, 2.018 is the lowest value. The answer, what is the lowest value of moles of the element? That is 2.018. So simpler molar mass we can get 4.07 divided by the lowest value of the moles of the element among these three, that is 2.018, right? Like similar manner we can get of the carbon and chlorine molar mass, simpler molar mass we can get this moles of the element divided by the smallest value we can get from this, that is here 2.018. 2.022 divided by 2.018 will get to 1.001 and 2.018 divided by 2.018, that is 1. So simpler molar mass we can get 2, 1 and 1, right? Therefore empirical formula hydrogen 2 is there, right? In simpler molar mass we can get the answer is 2. So H2Cl C is 1, carbon 1. So Cl, chlorine is also 1. So H2CCl. So after rearranging, this is CH2Cl is the empirical formula. Now we have to find out the empirical formula weight. Empirical formula weight we can calculate. That is 1 into 12. Carbon is 1 is there and atomic mass of carbon is 12 plus 2 into 1, 2 hydrogen atom and 1 is the atomic mass of hydrogen and 1 into 35.5, that is atomic mass of chlorine, that is equal to 49.5 is the empirical formula weight. Then you know the relationship between molecular mass and formula mass. Molecular mass is equal to n into formula mass, right? So n, you can calculate n. Now molecular mass is there given here, molar mass, and formula mass also already calculated. So from this we can get the value of n, 98.5. Sorry, this is 98.96 divided by 49.5. We can get 2. 2 n value. What is the n value? That is 2. Therefore molecular formula we can represent it as CH2Cl in subscript n, that is CH2Cl2. We can multiply here C2 2 into 2 H4 and Cl2. C2H4Cl2 is the molecular formula of this compound. This is the problem solved by step. This table make it easy to solve the problem. This is 4 mark or 3 mark question in the examination. Write this table and learn the steps and remember the steps. Don't by heart, remember the steps. Find out the molecular formula and empirical formula. First you should calculate the empirical formula, then you should calculate the formula weight, empirical formula weight, then you should apply the relationship between molecular mass and formula mass and substitute the values and then find out molecular formula. Molecular formula always empirical formula in subscript n. That will give molecular formula. N is calculated from molecular mass divided by formula mass. This is about empirical formula and molecular formula. Thank you.